In many languages, when you see the word collections, you immediately think of going to the language's standard library and getting some kind of list, map, or dictionary. These data structures are so common that the designers of Go decided that it made sense to build these basic structures directly into the language. The first collection type that we're going to look at is the humble array. An array is a group of data elements of the same type that are stored together in memory. While they can be very useful, they are constrained to have a fixed size and therefore not commonly used in Go. However, they underlie a very common collection type, so let's explore how to work with them. We create an array by starting with the array size in square brackets and following it with the data type. Notice that, once again, things are a bit backward from what you might have seen in other languages. The last thing we need to do is put these curly braces here. We'll get back to these in a moment. For now, we can assign values to each element in the array by typing the array's name, followed by the index that we want to work with, once again in square brackets. Arrays are a bit too complicated for the built-in println function to print, so we're going to use the FMT package to help us out this time. We'll use its println function to print the array out and see what we get. As you can see, we have each element of the array printed nicely for us. In order to reduce some of the redundant code that we have, we can use the array's initializer to set the values. That's what the curly braces here are for. We can add the data elements in order to the array, separating each value by a comma. One other advantage that we get with this is that we no longer have to explicitly tell Go how big we want the array to be. As long as all of the values are in the initializer, we can replace the size with 3 periods. Go will then create an array that is exactly large enough to hold the data. With the initializer in place, we can get rid of these lines and rerun the program. Once again, we get the same output that we had before, but with a much more concise and efficient syntax. If you ever need to know the size of an array, you can use the built-in len function. This function can be used for many data types and collections. As we can see, when we print the result of that function, we get the expected value of 3 printed to the console. As I mentioned before, arrays are not often used directly in Go. Instead, a more flexible data type called a slice is used. A slice represents a subset of an array, a fact that, on its own, is of marginal use. However, the underlying array can be managed by Go itself, allowing you to add as many elements as you want to the slice, and Go will take care of resizing the underlying array as needed. For now, let's create a slice of the current array. The fastest way to do that is to call out the array and then append square brackets with a colon in between. Optionally, we could also include an index before the colon to select an element other than the first one. We could also add an index after the colon to give the ending index of the slice. By just including a colon, we are telling Go that we want to create a slice of all of the values in the array. If we print the slice out, we see that it gives the same result as the array. In fact, if we changed one of the values of the elements, we'd find that both the array and the slice are updated. As I mentioned before, slices are more flexible than arrays because they can be resized on the fly, adding additional elements as needed. To show that, I'm going to juggle a bit of code around so that the array is printed before and after the new element is added so that we can see what happens to it. Now we'll assign the slice to the result of the built-in append function. That function requires the slice that is being appended to and the data elements to append. If we run the application again, we see that the array is exactly the same as before and after the append operation. However, our slice now contains 4 elements, with the new one tacked onto the end. When working with slices, you often don't care about the underlying array itself. Instead, you can let the Go runtime manage that for you. To create a slice, we can use a syntax similar to the one that we use to initialize an array. However, we don't need to give a size or the 3 periods inside of the leading brackets. Leaving them out means that we have a slice. Printing that out to the console reveals an error. That isn't how it's supposed to work. Oh, I missed the colon here that tells Go that I'm performing a short declaration. Okay, now everything's happy. We can also print the length of the slice using the len function again. As we expect, the value of 3 gets printed to the console. Something important to consider is that the array that underlies this slice is exactly the right size. While this works well for us in this scenario, it can be very inefficient if we are going to be adding a lot of elements to the slice, since Go will have to constantly copy the data to a new, larger array as more data gets added. To get around this, we can create a slice with a larger initial array by using the built-in make function. This takes 2 or 3 arguments. When created with 2 arguments, we create a slice with the size that we specify. The slice and its array are the same length in this case. If, however, we want a small slice to start with a large capacity, then we can pass a third value into the make function. The second parameter will be used to set the initial size of the slice, while the third will be used to set the size of the underlying array. For now, I've created a slice with a size of 100 elements and set some values for the first 3. If we run the program, we see that, as expected, we have 100 elements printed with only the first 3 having non-zero values. The last collection type I'd like to introduce is called a map. This data type holds multiple values that are accessed by customizable keys. Both the key and the value can be arbitrary data types. To create a map, we use the make function passing in the signature of the map. We start to define the map type by passing in the map keyword. We'll then give the type of the keys inside of square brackets and finish up by providing the type of the values. In this example, we've created a map that holds string values organized by integers. We can then assign an entry to the map by telling the map where to store it and then passing in the value. Let's do this a couple of times and then print out the map again. As a final test, let's try to print a value of the key that we haven't assigned. Running the application shows that we start with an empty map as expected. After we assign the 2 values, they are returned to us in the printed output. Notice the impact of the third print statement. Once again, we've gotten the 0 value for our variable, an empty string in this case. Go does not throw an error or print a nil value when we ask for the data that isn't present. It just silently provides a placeholder value for us to work with.